In our modern world, one of the most critical environmental challenges we face is the reduction of sulfur emissions. These emissions, often produced by large industrial processes, contribute significantly to air pollution and acid rain, causing harm to both our health and the environment. It's here that the process known as flue gas desulphurization plays a pivotal role. Flue gas desulphurization, or FGD, is a set of technologies used to remove sulfur dioxide from exhaust flue gases of fossil fuel power plants and from the emissions of other sulfur oxide emitting processes. It's a key method in mitigating the impact of sulfur emissions. So how does this process work? Well, it's a fascinating journey. The first step in flue gas desulphurization is the introduction of a flue gas into the absorber. The gas is typically rich in sulfur dioxide, a byproduct of burning fossil fuels. Next, an alkaline sorbent, usually limestone or lime, is introduced into the absorber. This sorbent reacts with the sulfur dioxide in the flue gas, forming a mixture of calcium sulfite and calcium sulfate. This reaction is known as absorption. Following absorption, the third step involves oxidation. Here, the calcium sulfite is oxidized to form calcium sulfate, also known as gypsum. This gypsum is then collected and can be used in the construction industry, turning a harmful waste product into a valuable resource. The fourth and final step in the process is the removal of the desulfurized flue gas. This gas, now significantly lower in sulfur dioxide content, is safely released into the atmosphere. So, there you have it. A step-by-step walkthrough of the flue gas desulfurization process. It's a complex yet crucial process that plays a key role in reducing sulfur emissions and mitigating their environmental impact. But why is this process so important, and what benefits does it provide? Well, the advantages of flue gas desulfurization units are manifold. Firstly, they reduce the amount of sulfur dioxide released into the atmosphere, contributing to cleaner air and a healthier environment. This reduction in sulfur emissions can also mitigate the effects of acid rain, a significant environmental concern. Secondly, the byproduct of the process, gypsum, can be used in the construction industry, providing an economical and environmentally friendly solution to waste disposal. Lastly, by implementing flue gas desulfurization units, industries can comply with stringent environmental regulations, avoiding penalties and contributing to a sustainable future. In conclusion, flue gas desulfurization is a vital tool in our efforts to reduce sulfur emissions. It's a sophisticated process with significant benefits, turning harmful waste into valuable resources and contributing to a cleaner, healthier world. From cleaner air to the creation of useful byproducts, the importance and benefits of flue gas desulfurization units are clear. They're not just a solution for today, but an investment in our future.